Hello, revered geometry class. Welcome to our third week of online learning. This week we'll actually be jumping forward just a little bit. We're skipping the second section of chapter 9 for now. That is a section regarding constructions, which is an important one. However, it isn't really the most suitable for this online learning format right now. So if there's a chance of doing that in person, I'd prefer to wait and do that together um, and jump into some exciting circle work here this week. In chapter 10, we're moving a little bit away from areas and circumference of circles and into some other important ideas. It starts in lesson 10.1.1 with ideas related to arcs of circles. We'll talk about major and minor arcs and what those are. We'll also talk about what a chord is in a circle. So those are key definitions. Be sure to watch for those words as you go through this lesson. Um, we'll be working with how you can use just a small portion of a circle's circumference to actually backtrack and find its overall circumference or its area. Um, you'll have a resource page which does have good information. You can click that through your ebook, and it gives you some things that you can trace onto your own paper. You do need a straight edge, like a ruler. If you have your own compass, that would be a helpful tool. That's a tool that allows you to draw a circle. However, we can also talk through that because I understand that not everyone doing this will have their own compass at home. So we'll talk through the part that you would be required to use a compass on. Um, from the feedback on the Google form that you completed, I did make sure that I corrected the answer key. Those are now screenshots that are properly formatted, so be sure you use those to support you in your work um, as you go through this assignment. And then once you've completed, you'll return to this video so we can recap and make sure you saw the main ideas. But first, try to do it on your own. Right now, I'm going to go ahead and pause, and you can pause this video. And then when you return, we'll go over some of the key ideas from this lesson. All right, good luck, guys. All right, so welcome back. Hopefully, you're now joining me in this video because you've completed the entire lesson. This one did have some different ideas that we haven't studied a whole lot before, so I want to make sure that we kind of thoroughly talk through some of these problems. The first question deals with having only part of a circle called an arc, um, and how we can use that to find out a little bit more about circle. So in this situation, we had someone who found just a segment of a tree that's shown shaded in that circle that says tree fragment. But then also on the resource page, we were given that arc AB and asked if we could work with that. So let's sketch arc AB. And I'll warn you ahead of time that I am not using a compass on my iPad to avoid any damage, but we can still work with it a little bit. So doing my best to draw us a good arc. There we have AB. And we were asked to see about finding the center of the circle. So one strategy you could use here would be to trace this on your own paper and fold this arc onto itself so that point A matches up with point B. What that'll do is that will create a crease running vertically like so. Well, by itself, that crease doesn't do a whole lot, but now, if you were to do something like fold so that point A matched up with this new point, let's call it E, on the circle, you would get another crease right in the center of that arc that should intersect your original crease somewhere. We could do it a third time with B and E, and the same thing would happen. Oh, let me try that one more time. And what we've just done is we've created these lines that intersect at the center of the circle. So that's how you could use that arc and just paper to be able to find where the center of the circle is. Once you've done that, you were asked to figure out if 1 centimeter represents 10 feet of the tree, find the approximate lengths of the radius and diameter of the tree. Does it appear to be larger than 45 feet in diameter? So for that, you would need to use your own ruler to measure the lengths of the radius that you got drawing from the arc of the circle that we were given to that new center point. And you should see that, yes, that does appear to be larger than the original 45-foot diameter tree. So if we continue through the lesson, 10.2 was pretty important because this is where all of our new vocabulary comes from. So they explain that a chord is a line that connects with endpoints on the circle that doesn't pass through the center of the circle. So it's not a diameter, but it does connect with endpoints on the circumference of the circle. We also broke down an arc to be either minor or major, because when we draw an arc like AB that is shown darkened on that circle there, it actually creates two arcs. You have the one that's dark, and then you have the remaining section of the circle which is not bolded in. So the minor arc would be the small one going from A to B, and the major arc we'll use a 3-letter naming system for, so we'll include that point C and call it arc ACB, and that would be the major arc because it's the larger of the two. So that's a way that we can distinguish between the small and large arc created when we select one. Going on to 10.3, this was a chance for you to use a little bit of an idea of proof by a counterexample. And in 10.3, it's really important you realize the diagram that they've drawn is not guaranteed to be correct. That's a hypothetical situation saying, what if we had a chord AB and a line perpendicular and bisecting it that didn't run through the center? So that's why they've drawn the center away from that. And an idea you could use, they helped us create triangles ACD and BCD, which would go to the center. And if you created them right on this diagram, they wouldn't appear to be congruent. However, if you use your knowledge of angles and that right angle there, you could then work your way into the fact that angle ADC would have to be a right angle as well. You see that AD and BD are marked as congruent to one another, and you know that DC will be the same by the reflexive property for both triangles. So you actually have side angle side right there, proving that those triangles must be congruent. And if they're if they're congruent, then it follows that the center, that point C, would actually have to fall on that line, because otherwise there's no way for the hypotenuse BC to be different than the hypotenuse AC on the other triangle. So that's a way that you could really justify that if you create the perpendicular bisector of a chord, it will pass through the center of the circle. 10.4 goes back to the resource page. This time you've got just chords given and no arcs, and you're asked to see if you can come up with a way to find the center of the circle and then work from there. One method would be to trace this onto your paper and fold those chords so that their endpoints match up. Those folds would create the perpendicular bisectors that you know pass through the center of the circle now. So you could then identify the center where those two new creases intersect. And once you've done that, then you could take your compass, put it with the point at the center, and then place your pencil at the end of one of those arcs, or one of those chords, and draw a circle that would be accurate there. In part B, however, they say, how would you find the center of the circle without tracing paper? That is, how would you find the center of P with only a compass and a straight edge? That goes back to ideas of constructions. And again, this would be pretty difficult without a compass, and that's part of why we were skipping that construction lesson for now. But so if we do look at that, and that means I'm going to copy, let's look at circle P here. So just roughly sketching the arcs shown in, or excuse me, the chords. I don't know why I want to call those arcs. So if we work with these chords and we just have a compass and a straight edge, one thing we could do, I'll put some letters to name the endpoints. You could use your compass placing the sharp edge on point A and your pencil on point B to draw what would ultimately be an arc of a circle. You could then reverse that and put the sharp edge of your compass on B and your pencil on point A to draw another arc. By doing that, if you were to use your straight edge to connect where those arcs intersect, you would end up getting the perpendicular bisector of chord AB. So what I just drew is the perpendicular bisector. Now remember, I'm not using a compass on my iPad because I don't really want to damage things. It wouldn't work out all that well, I don't think. But this would be perpendicular, and it would bisect that. You could then do the same thing for arc CD, and where those lines intersected would provide the center for the circle. Then once you knew the center, you could use your compass to put the sharp edge at the center and the pencil at point A, and then draw your circle, which should connect all your points. So that's a process that you could use to get that circle without having to use tracing paper. Problem 10.5 was one last good one, using what we know now about chords a little bit. It would require drawing a triangle from Z to X or Z to W, and then making it a right triangle so that it used only half of WX as its base. And by doing that, you would know that WX was, or excuse me, half of WX was 4 units, and then the radius from Z to W would be 5 units, so you know 2 sides of that triangle. And if you drew the height, which is perpendicular to that chord, you know it would be a perpendicular bisector. So you have a right triangle because it's perpendicular, and you know 2 sides, which are 4 and 5. So if I'm using my triangle knowledge, I would say that that height would end up being 3 units because it's a 3, 4, 5 right triangle. And that's something you can draw and verify on your own, thinking about not only drawing the big triangle from Z to W to X, but then splitting it down the center to make a right triangle. All right. Hopefully you picked up some new circle skills and a little bit of circle vocabulary. You can review that in the math notes as well. Your homework tonight is to complete the review and preview. Please skip problem 10.8. You can read it if you'd like, but it's related to constructions that you didn't really study yet, so it's not one that you need to go ahead and work. All right, guys, once you're done, take a screenshot and upload it. As always, I'll be having office hours from 9 to 11 all week, so please stop in and let me know if you have any questions. All right, good luck.